This is the second lecture of our IMAT series. Today we are studying about ideal gas laws. Okay. First of all, we will see gases, liquid, solids properties. Uh, we discussed it so much in our previous lecture. Uh, so, gases, liquids, and solid gases particles are far apart, very compressible. Liquid particles are like not far apart like gases. They are little bit close. They are slightly compressible, while solid particles are closely packed and incompressible. These are the densities. You can see here comparison here. Gases have no definite volume. Liquids have definite volume. Gases, liquid, and solid. Solid also have definite volume. Gases have no definite shape. Liquids have no definite shape. Liquid takes the shapes of the container. Solids have definite shape. Okay. Properties of gases. Uh, Amount, mass or moles, lower molar mass, independent of volume, amount of mass, independent of volume, pressure, and temperature. Okay, volume, gas takes shapes of its container and completely fills it. Okay, volume of gas is equal to volume of container. Volume depends on pressure and temperature. These are the properties of gases. Temperature, both P and V depend on temperature. Both pressure and volume depends on temperature. uh, this is the most important point. Uh, Doing calculations, we have to convert every temperature value into Kelvin so we can get our correct answer. All gases are miscible, mixed completely, homogeneous mixture. Pressure. Pressure is force per unit area. This is the diagram. You can see particles are uh, putting force on the walls of the container, and when they collide themselves, they also create pressure. Gas particles exert pressure by colliding with the walls of container. More collisions per area, higher pressure. More collision per area, higher pressure. Less collision per area, lower pressure. Uh, this depends on pressure depends on V and T. As the unit of pressure Pascal, 1 Pascal is equal to 1 Newton meter per square. Okay. Pressure measurement. We use barometer. Okay. Pressure of atmosphere, manometer, pressure of gas or gas power liquid in a vessel. Okay. Units: standard atmospheric pressure, average atmospheric pressure at 0 degrees Celsius at sea level. That's what these are the units of pressure. You can see the conveyance here. 1 atmosphere is equal to 760 millimeter of mercury, and 760 torr, and 101325 kilopascals, and 1.5 lbs per inch square. Okay. uh, this is the example here. This is a question: what will be the height, and this is not related to IMAT, I think. So you see here, when it is closed, pressure of gas is equal to, I think this is not included. So going on to the main topic, uh, gas laws. Gas laws. First one is Boyle's law. In Boyle's law, volume is inversely proportional to pressure. Okay. At constant temperature and fixed amount of gas. Using proportionality constant, we will get this equation this way: PV is equal to K. Okay. Uh, Here are some graphs. V and P. We will get the isotherms when we place a graph, and we get a straight line when we plot a graph between V and inverse of P. Okay. Because V and P are inversely related, so we will get a straight graph when we plot a graph between them. Okay. uh, this is the equation we can use when we were solving the numericals, uh, according to Boyle's law. Like when we have given P1, P2, and V1, we have to find V2 like this, and sometimes we have given uh, V1, V2, and P1. Also, we have to find P2. Here's an example. Um, y- Sometimes don't worry about units. We like we have to see the units of temperature mostly, because according to Charles' law that we discussed later. Okay, so you can see example here. 3 foot cube tank. To what pressure must a gas be compressed to get it into 3 foot tank if it occupies 450 at? These are the initial, and you have to find the final. So you will use this equation: P1 V1 P2 V2. You will get your answer. Try to solve this yourself. uh, Second gas law, Charles law. Volume is directly proportional to absolute temperature, constant pressure at constant pressure, and fixed amount of gas. Okay, so uh, according to this law, volume is directly proportional to temperature. Using proportionality constant K, we will get this equation for Charles law. Here's graphs. When we plot a graph between temperature at Kelvin in Kelvin scale, okay, with volume, we will get a straight line. Okay, but when we get this, we get a straight line, but it is not touching the origin. This will reach out to absolute zero. Absolute zero values 273.15 degrees Celsius. Okay, so I hope you get this. Here's a question here. You can use the formula above. V1 over T1 is equal to V2 over T2. Okay. Here is the formula. This one. This one. Okay. Avogadro's law. Okay. Avogadro's hypothesis: equal volumes of gases at same temperature and pressure contain equal number of particles. What Avogadro's law says? Volume of a gas is directly proportional to a number of moles of a gas. Using constant, we get this equation. We can use this relation in our numerics problems. And here's a question: determination of mole with respect to, if gases have equal number of volume, then there are equal number of particles. Yeah, mass of molecule B AMU is equal to mass of V, and this. Okay. Uh, yeah. There are two balloons at same temperature and pressure. One balloon contains H2, another contains an unknown gas. B each with respect to volume 1 liter. Masses are shown below. What is the uh, mass with respect of B? Okay. Uh, you can um, you can use previous formulas to solve this problem. Okay, you have given some details here. Try to solve it yourself. If any confusions in the question, let me know in the comment section. Okay. Here ideal gas laws. Let us see some assumptions. I will let you know some assumptions of ideal gas laws. Uh, Actually, I can write here. Assumption first one is zero particle volume. Zero particle volume. Okay, zero particle volume. Okay, and then next second one is no intermolecular forces. These are the assumptions. No intermolecular forces. These are the assumptions of ideal gas laws. Like we assume particles to be like tiny. Okay. Here, what ideal gas law says. Okay, volume is inversely proportional to pressure. Volume is directly proportional to temperature. Volume is directly proportional to number of moles of a gas. Okay, this is Boyle's law, Charles' law, and this is Avogadro's law. Combining these proportionalities, so we get this by using proportionality constant. We get this equation. R is a proportionality constant, or ideal gas constant, or general gas constant. Okay, the value of R is this. These are the units. Okay, this is not an SI unit. Okay, ideal gas, hypothetical gas that behaves according to Alexander. Real gas behaves as ideal gas when real gas will behave like ideal gas. When low pressure and high temperature is provided, real gas will behave like ideal gas. Okay. Some conditions here: standard temperature and pressure. Temperature and pressure affect volume. We need standard temperature and pressure as a reference point. STP, standard temperature and pressure. Temperature is equal to 0 degrees Celsius. Standard conditions these are 273 Kelvin. Pressure is 1 atmosphere. This is standard conditions. Okay, molar volume. Volume of 1 mole of an ideal gas Vm at a given temperature and pressure. At STP, 1 mole of a gas contain standard temperature and pressure. 1 mole of gas contain 22.414 liters. 2.22.41 liters of volume. Standard molar volume. You can write it like this. Vm. We can write it Vm. You can calculate this. What volume does 3 moles of gas occupy? Like 1 mole contain 22.4. You can calculate 3 moles for 3 moles by yourself. Okay, let me show you. 3 multiplied 22.4, you will get almost 67, probably 67 point something. Okay, you can multiply it. Yeah, alternative of ideal gas law. Okay, like the real equation is PV is equal to nRT. Okay, nRT in like multiplication. nRT goes down, and we will get this equation for R. Like when we have given 7 values out of 8, we can calculate the 8th one. Okay, 8th one. Calculation using ideal gas laws. Given any 3 PV and T, calculate the unknown quantity. Okay. What is the pressure in a container that holds this? You are given mass, you are given volume, you are given temperature. You can calculate moles by using this. Ammonia's molar mass is 17. Using this, like these are probably be solved by calculators. So in IMAT you don't have a calculator available. So try to solve those equations which are solved without a calculator. These are the examples you can. Yeah. um Molar volume and molecular formula. The molecular formula is calculated by this empirical formula into n. Okay. Okay, you can calculate density by this method. This is the equation PIV is equal to nRT. As we know, n contains number of moles is equal to mass over molar mass. Mass over molar mass. So n goes down, and molar mass will be equal to m over n. Okay. So we will write m over m in place of n. Okay. We will write this, and we know that n v goes down in this equation. Uh, like here you can see P is equal to n is replaced by mass over molar mass. Okay, m over m RT, and V goes down. We write V here. So m over V is density. You can see here formula is density. We will write this like this. P. This is mass. This is molar mass. Sorry, this is mass. Mass over volume is equal to density. P is equal to density R. Uh, P is equal to density R T divided by molar mass. So this equation be like this: density is equal to pressure multiplied by molar mass divided by general gas constant multiplied by temperature. Okay. Hmm. Some stoichiometry problems using gases, involving gases. Uh, okay. Moles of reactant products are by balanced chemical equation. Uh, you can use these equations when number of moles are given, and we have to find the volume of a gas. Okay. Here in the example, you can solve it. What volume of oxygen gas will be required to produce 0.5 liters of CO2 by the following reaction? You have given moles. You have given moles ratio here. You can calculate that. If you don't understand this, you have to learn the topic. Stoichiometry video is available on the channel. You can see there and try to solve these questions. Okay. Yeah. Gas mixture and partial pressure. This is one of the most important topics as well in ideal gas laws. Each gas acts independently. Total pressure depends only on the total number of particles and not kind. Okay. Partial pressure. Pressure each gas will exert if it were the only gas present at the same temperature and pressure as for the mixture. Densel's law of partial pressure. Pressure total is equal to partial pressure 1 plus 2 plus 2 plus 3 plus so on. Okay. This is the equation. Assume each gas behave widely. You can use this equation to find the pressure. Okay. A lot of like some questions appeared of mole fraction and partial pressure in IMAT exam. So you have to read this topic. This is mole fraction formula, total pressure under here, and you can see pressure of a gas and total pressure and mole fraction. Okay. Related to partial pressure, this you can see you can use this equation. If you have to find the partial pressure, you have pressure of a gas, total partial pressure, and you can find the pressure of a gas. Okay. Here's an example. You can find mole fraction like this. Okay. By dividing this, when you find the mole fraction, you will find the partial pressure of a gas. Okay. Try to solve these questions. First of all, you have to find a partial pressure of O2. Okay. First of all, you have to find the moles of both substances. Um when you find the moles of both substances, first of all you have to find the moles. N is equal to mass or molar mass. You will find moles of oxygen, O2, and moles of helium. Okay, O2 and helium. Then you have to find the mole ratio of oxygen. Mole ratio of oxygen by moles of oxygen divided by total number of moles. Total number of moles contains O2 and H2O, He, helium and oxygen moles. Okay, you will find mole fraction. When you will find the mole fraction, you will have to find the partial pressure of O2 by using this formula. Pi is equal to mole fraction of oxygen and total partial pressure. Okay, I have given you the hint. Solve it by yourself and do more examples like this. Okay. Collecting gases over water. Gases product is collected in an inverter tube of H2O water. Total pressure gas plus H2O. So you can find pressure of a gas by subtracting pressure of a water from total pressure. Okay, these are yeah. Kinetic molecular theory. Explain behavior of ideal gases. A gas consists of molecules in constant. According to this theory, a gas consists of molecules which are constantly in motion, colliding with the other particles and molecules and with the walls of the container in which they are present. Okay, this is the kinetic energy equation, and URMS is root mean square speed. You can use this formula to find kinetic energy of particles. Here are some important postulates of kinetic theory. Molecules move continuously and randomly in a straight line in all directions by speed. Like molecules have no fixed direction. Like they will move in one direction. They will collide with the walls of the container, bounce back, takes another direction, hits the other molecule, and then moves towards other molecule, and then again hit the wall of the container. So they are moving randomly, hitting one another and the walls of the container. Properties of a gas depends on motion of molecules, such as pressure will be same in all directions. In which direction they move, the pressure will be same. Okay, gases are composed of molecules whose size is negligible compared to the average distance between them. And the gases are composed of molecules. The particles of the gas I told you earlier, they have zero particle. Particles have zero volume. Zero volume. We consider them negligible, like so tiny. Most of the volume occupied by the gas is an empty space. you can see the most volume occupied by gas is the empty space. I told you earlier there are no more intermolecular forces, zero particle volume, so volume occupied by gas is empty. Yeah, you can see ignore the volume occupied by the molecules. Intermolecular forces, attractive and repulsive forces between molecules are negligible. I told you in the start of the lecture that intermolecular forces are not present, like they are like of no importance, like we don't see any effective forces between the particles. Yeah, this is the point, except when the molecules collide with each other. So we can say no intermolecular, negligible, they are like we can't see some forces between them. And number four, molecular collisions are elastic. Energy can be transferred between molecules, but the total kinetic energy remains constant. Total kinetic energy remains constant. Uh, okay, when kinetic elastic collisions, kinetic energy is constant. Okay, the average kinetic energy of the molecules is proportional to the absolute temperature. The average kinetic energy of the molecules is proportional to the absolute temperature. The higher the temperature, the greater the average kinetic energy. Okay, ideal gas, hypothetical gas, which conforms to all the assumptions of KMT, kinetic molecular theory. Real gases obey kinetic behave ideally at high pressure and low at high temperature and low pressure. High temperature, kinetic energy great enough to overcome IAF. Okay, intermolecular forces. Okay, low pressure, few particles in a large volume. Molecular speed, distribution of kinetic energy, and speed is dependent on temperature. Total kinetic energy of 1 mole of gas. Here is a formula for this: 3 by 2 RT. Average kinetic energy of one molecule. You can use this formula. Yeah. Okay, these are like Avogadro's numbers. Na. By substituting values, you will finally get this equation for the speed: 3 RT square root 3 RT over m. Here's a formula, calculate the speed. You have given some details here. Calculate this. Okay. Qualitative interpretation of gas laws. Pressure caused by the collision of molecules with respect to container walls. Frequency of collision per unit area. Force per collision. Molecular concentration. Average speed determines the frequency of the call. Average molecular speed determines average force. Okay. Boyle's law. Temperature constant. Kinetic energy constant. Internal energy constant. Okay. This is. I'm sorry. I think this is the. Okay. 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 Increase volume, molecular concentration decreases, frequency of call per unit area decreases, pressure decreases. Okay. Charles law, temperature increases, kinetic energy increases, internal energy increases force, increase in collision. Keep pressure constant, volume must increase, so the molecules per unit volume and frequency will decrease. Temperature increase, volume increase. As we know, volume and temperature directly proportional. Some properties of gases, effusion, dispersion of a gas throughout a vessel. These are general things. Effusion gas molecule escape through a container. This is an important topic. Rate of this is Graham's law. Rate of effusion is directly proportional to internal. Okay, R is directly proportional to U. R is this is the formula of U. Yeah. Graham's law of effusion. R is directly proportional, inversely proportional to square root of molar mass. At constant pressure, temperature, and pressure, by using constant, we will get like this is R1, this is R2. You can use this equation. Uh, so you will get this equation at constant temperature. This is Graham's law, rate of diffusion. If we have rate of diffusion given, if we have this given and this one given and like this one given, we can find another. Okay. Yeah, here you see rate of diffusion of unknown gas is 291 faster than that of NH3. So we will put 292.91 here and x here, so it will cancel, and okay, you can find by using this formula. You have to find molecular weight. Okay, what is real gas? Real gases deviate from ideality at high pressure and low temperature. They will deviate, but they will show ideality at low pressure and high temperature. Some assumption made in KMT are false, like we made assumption, but these are not true. Molecules do not interact. Non-intermolecular molecule volumes are negligible. Remember, for an ideal gas, PV nRT is equal to 1 at all. This is for ideal gas. Okay. PV over RT over 1 mole of gas. These are some graphs. Okay, when the value is 1, it will show ideal gas. Ideal gas will show this path. Like the real gases show like this. Some will show straight, some will show curves graph. Yeah. So on it. So this is today's lesson. If you have any confusion or you are unable to solve some MCQs or some equations I have shown you, let me know in the comment section. Hopefully you will understand today's topic. You can see our previous lectures on our YouTube channel, and good luck, and don't lose hope. You will surely clear IMAT. Best of luck for the exams. Leave a comment if you like this lesson.